All right, so let's see who is then worrying about all this climate change. That is a global problem, so probably you need a global organization to do that. Uh, we already said there is always controversy and debate about climate change. Anything international actually tends to become not so trusted by some countries. Let's not mention any names, but nonetheless, I think we know who we are talking about. So we talked about natural causes of climate change. Pleistocene is the time period in the past where we looked at last couple of million years ago, and we call it Pleistocene glaciations, where the time scale switched from 41,000 years in the records, paleoclimate records, to a 100,000 year cycle. So the last ice age went, for example, from 120,000 years ago to the last to about 18,000 years ago when it started to end, and now we are in a deglaciation. So the ice age has ended, and it's all relative, right? Because there is still glaciers on Greenland and Antarctica and several mountains like the Himalayas, Andes, and so on. So what is a what is the difference between an ice age and a deglaciating age? So it's relative. When there is extensive glaciation on continents that came down all the way to New York and down in Europe and so on, we call it glaciation, but as you can imagine, it's relative. And we have had smaller ice ages, like the Little Ice Age, which was mostly documented on Europe. In Europe, the medieval warm period, we know that it was only warm by a degree or so relative to the base period, but it led to lots of changes, like colonization of Greenland by the Vikings. And when the Little Ice Age started, the Vikings went extinct. So there are many civilizations that have gone extinct along the way: the Mayas, the Incas, Mohenjo-daro, Harappa, and so on. And the monsoonal changes over Sahara led to large migrations as well. These are all naturally forced, orbitally forced climate change. And human CO2 emissions over the last 130 years have been actually quite large. Again, relatively speaking, because if we go to 65 million years ago, we find CO2 concentrations in the atmosphere as high as 8,000 ppm. Right now we are at 415, but back then it was 1,000 ppm. Climate was different. No glaciation on Greenland and Antarctica, no ice in the Arctic, but we were also not around. So it's not like we can let the climate go back to those kinds of temperatures, because we don't know if we would survive that. Okay. So yearly emissions are now almost 130 times greater than volcanic CO2 emissions. Okay. 130 years, scratch that. Since industrial revolutions, 200 years, we've been putting out CO2. We started with burning coal, then we moved to friendlier diesel and petrol, and then natural gas, but the story remains the same. They are all carbon intensive energy sources, right? Recent changes are called unprecedented. So the agency, the organization that documents these changes, uses these words carefully because of causes like this. So you can look at the debate, scientific consensus of large human contribution, and as I said, there are cultural differences. Europeans and Americans behave very differently when it comes to discussing climate change or taking actions or making policies or negotiating at international meetings and so on and so forth. Australia is different, Canada is different, Russia is different. Fortunately, India and China have been very proactive in negotiating and starting renewable energy sources and so on. So this is just a survey. I won't go through it too much, but it's looked at at general public, non-publishers and non-climatologists, so educated people who publish papers but they're not climatologists, active publishers of all topics, and so on and so forth. There is a very nice website called Yale 360, Yale, Y-A-L-E, the Yale University in New Haven, Connecticut. They do very extensive surveys, and there is even a survey on India on the perception of climate change. Okay, so there are divisions based on whether you are a conservative politician, or political leanings are conservative or liberal, and so on. But there are subtleties, because in terms of the action to be taken, there is really not that much different. So just because people believe in climate change does not mean necessarily that they're doing a lot of things to save the world. But they tend to support policies, carbon taxes, building codes, and other environmental regulations that try to reduce the human impact. So there is a difference, but what we do individually can be almost the same, because that takes behavioral change, as we said. That's not easy for anybody. Okay. IPCC, the Intergovernmental Panel on Climate Change, started publishing its reports since the 1990s. Now it publishes every 7 years. 1990 was the first one. I think 97 was the second one, or 95, and so on. The last one came out in 2014. Obviously, the next one is due in 2021. And this is massive work. Several hundred scientists formed several committees and looked at all aspects of climate change. And they write massive reports on what is observed, what is documented, what the science says. So literally thousands and thousands of published scientific papers are synthesized into what we know about climate change. Okay, and evidences like this are used. Here we go with our Keeling curve again, with the annual cycle, and the blue line is without the annual cycle, and you can see that there is a corresponding decrease in atmospheric oxygen. Who's measuring this oxygen? So, the cute little fact is that Charles Keeling's son Ralph Keeling, who is at the Scripps Institute of Oceanography, started these measurements just recently, like in the 1990s. So he's the oxygen expert. But there are other evidences as well. So as the global emissions of carbon in gigatons per year, so the concentration is in the air, parts per million. Emission is what is being put out by burning fossil fuels. That is measured in how much carbon in gigatons. I think you know what is mega, giga, tera, peta, and so on. Giga is 10 to the 9, so that's a million, 1,000 million tons per year. So obviously we've been increasing our emissions over time. This is already old, only 2005. But there is this other evidence shown on the right side in the red line, that is the change in the C13 in the atmosphere. We looked at O18. C13, we will talk a little bit more. Basically CO2 that is captured by photosynthesizers fractionates carbon as well. It's always about energy efficiency. So C13 is heavier, so the plants and photosynthesizers prefer to take up C12O2 when they can, but if the concentration drops, they take more of the C13 to get enough CO2 that they need. So you can look at the CO2 and the C13 versus C12 content and see where it comes from. What are fossil fuels? Basically, they're hydrocarbons produced by photosynthesizers in the past that was buried, and now we are digging them up and burning them, right? So if they're photosynthesized, that means they would be depleted in C13, because photosynthesizers preferentially take more C12O2 than C13O2. Cute, right? So if the concentration of um, depleted C13 CO2 continues to increase in the atmosphere, then that is consistent with the fact that it is coming from burning fossil fuels. Okay? Just remember, fractionation is common for life forms, C12, C13, O18. There are other calcium carbonate we have talked about, and so on and so forth. So this is podcast is a little bit long, but maybe I'll stop this and start this slide in the next podcast. It's about the detailed documentation of the changes that the IPCC reports in these massive reports they produce every 7 years. So we'll look at that in the next podcast.